This is proof number 22 of the Pythagorean theorem. We're trying to prove that the square of the length of the hypotenuse of any right triangle is equal to the sum of the squares of the lengths of the other two sides. So we started with a generic right triangle, ACF, with our right angle at point C. We constructed an altitude from point C over to side AF. The foot of this altitude is point P, and notice that angles APC and FPC are right angles. We constructed circles using each side of our right triangle as the diameter of the circle. So we have circles AC and CF and AF. Notice that point P is on the circle CF down there. Angle CPF is a right angle, and it intersects the diameter CF, so point P must be on that circle that has CF as a diameter. Also, angle APC is a right angle and intersects diameter AC, so angle APC must be on circle that has AC as diameter. Therefore, point P is on both of those circles. And I also want you to notice that the length AF is equal to the sum of length AP and PF. Notice that CA is tangent to the big circle at the bottom, so we can use our secant tangent theorem, which tells us that the length of CA squared is equal to the length of AP times the length of AF. Also, CF is tangent to the big circle, so the measure of CF squared is equal to the measure of AF times the measure of PF. We can add these two equations together, and that gives us CA squared plus CF squared is equal to AP times AF plus AF times PF. Now notice on the right-hand side, the measure of AF is a factor twice, so we can factor that out using our distributive property. And the right side becomes AF times the sum of AP plus PF. And we've already established that AP plus PF is equal to AF. So the right side becomes the measure of AF squared. So now we have the measure of CA squared plus the measure of CF squared is equal to the measure of AF squared, and that is the Pythagorean theorem. The length of the hypotenuse squared is equal to the sum of the squares of the other two sides.